Hello again, welcome physical science students to the next video in our metallic bonding series. This time we're looking at how we can modify metals. In the previous video we were talking about how metals can have a crystalline structure, and whether those crystals are large and small determines whether or not it bends or is hard. And so we can actually modify metals, and by modifying metals there are a number of ways of doing it. Whoops, that was a double click. One is by what's called work hardening, or treating it by heat, and another way is alloying. And we'll just quickly go through those. We don't need to know too much about it, but we do need to know, and we'll be doing a prac on this as well. So modifying a metal by work hardening. Bending or hammering cold metals causes their crystal grains to become smaller. Since bending is made more difficult, if you think back to the ball bearing models, if you have small crystal grains you have lots more dislocations and boundaries, and so the metal resists bending and becomes brittle. So if we hammer them and we make the crystals smaller, it's toughening the metal, or work hardening. And work hardened metals are usually more brittle because of all these dislocations. A couple of examples you might think about, like we're going to do a prac on it with needles, so you'll see it. But if you're hammering in nails can get quite hot through hammering, and then when you pull them out they become brittle. If you get a coat hanger wire and bend it and bend it and bend it, it will eventually snap. And what you're effectively doing in the middle is you're heating it and you're hammering it, even though bending isn't hammering, and you're making smaller and smaller crystals, and eventually it's making it really brittle and it snaps. If you ever need to break wire, that's one way of doing it if you haven't got some pliers around. It's why drill bits will break once they've been used a lot, because every time you drill into wood or metal you're heating up the metal and it's causing some recrystallization, and you keep doing that over and over and over, and the metal will become brittle. Same with hacksaw blades as well, and most metals. So that's called work hardening, and that's what blacksmiths used to do as part of their making metals. They used to hammer the metal into shape. Modifying a metal using heat, so not just by hammering but also using heat. So we can use heat a number of ways. We can have what's called annealed metals, which are heated and then cooled slowly. And so you heat them up till they're red or nearly white hot, and then allowing them to cool slowly allows all the cations to rearrange themselves, because when you heat them up they start jostling around and there's a little bit of movement, and then by letting them cool they can realign themselves and you end up with bigger crystals. And as we learnt just before in the last video, bigger crystals means a softer metal, because the cations are more easily sliding against each other because of more regular structure. Quenched metals are the opposite. When you heat them up again, but then you cool them very quickly, usually by plunging them into water, and so all those cations are suddenly frozen in their position, so you end up with smaller crystals. They don't have time to readjust themselves, and therefore it's harder and more brittle. So that's annealed and quenched. And then in between that are what's called tempered metals. Had to quickly pause there, back to it. Tempered metals, where we're at. Now these are in between the annealed and the quenched metals, and so what you do is you take a quenched metal, so something that's got small crystals already, that is brittle, you heat it up and then you allow it to cool slowly. So you're not making super big crystals, you're just allowing the smaller crystals to grow a little bit better and to interlock a little bit better, and so you're reducing the brittleness by getting rid of some of the dislocations and the empty vacant spots, but you're retaining some hardness. So they're the main three ways of modifying metals with heat, and we're going to explore that using a prac. So hopefully we should be able to do that fairly neatly. Now we can also modify a metal by alloying. You've probably heard of alloys. Now what do we mean by alloys? That's when we we are made from melting metals or other materials together and then allowing them to cool. So it's a mixture of metals, but we can also add other things in, only in small amounts though. Most alloys only have very small amounts of non-metals in them. The alloy will tend to have different properties from the metals that go to make it, and that's why we make alloys. So here's an example. This is what silver would look like. This is what copper looks like. Two things with very different properties. We can melt them, mix them together in a certain percentage ratio, and we get what's called sterling silver, which is not as soft as silver, doesn't tarnish as much, has a slightly different colour, but not very close to silver. And because silver is very expensive and copper wasn't so expensive when this was all happening, nowadays copper is quite expensive, it's a way of making silver, cheaper silver basically. This is iron with carbon. In this case it's a non-metal, and you're getting what's called steel or carbon steel, which has steel is much stronger than iron, has less tendency to rust, does rust still but not nearly as quickly as iron, and has a multitude of other uses. And you can see that in this case the carbon is sitting between the cations, where in this case the copper is replacing positions in the lattice. So we'll do a prac now on growing crystals, not only metal crystals but also ionic crystals. It's a pretty neat prac. If you work on it carefully, you get to see crystals actually growing. And I'll also on the OneNote put a link to this, or maybe a copy of this video, which is a video that just pretty much gives you another voice on bonding and metals. It takes 22 minutes of your life away, but it's well worth it, I think. And we should also be now able to do the chapter questions, multiple choice questions and the review questions, and that will be on our OneNote as well. Then, as an added bonus, get giddy, you can also watch the matching video that goes with this one on ionic bonding, and that's only 17 minutes. So that pretty much wraps up metallic bonding, apart from the stuff that we have to do in class. Cheerio!